Hello, everyone. If the Team 408 Masterminds are in the building, if y'all want to come down and check in with me, we're going to have your team sit up here for project presentation. So if you are in the building, come on down. And we're going to get these project presentations started in a few minutes here. Oh, perfect. Here they are. All right, good morning, everyone. This week was so much fun. I actually can't believe we're at the final day here of WAFFLE 26. But we have a really special closing ceremony planned here today, so we're really excited to finish this off and just conclude on a really celebratory and positive note. So to kick things off, we're going to have our project presentations. So we have 7 teams who are going to be presenting today. So the judges selected these teams as presentations that really stood out as being unique, creative, engaging, and something we think would be awesome to share with everybody here today. But of course, there were so many incredible project presentations by everybody here this week. It was a really difficult decision. So let's just have a quick round of applause for all of our teams that presented this weekend. And one of my favorite things about WAFFLE is this is an international event, and it's such a rare opportunity to have so many people from so many different countries gathered in one place, really working towards the same common goal, the same mission, to inspire our students with STEM and get them excited, wanting to pursue careers in this field, and along the way, becoming really compassionate and thoughtful teammates. With that international aspect, we recognize that for many of our teams, English is not their first language. So presenting in English, that adds an extra level of challenge. So we really commend and applaud you for taking that on. So let's have a round of applause again for our international teams. It's really been so amazing to see all of these beautiful cultures being shared and getting to celebrate that together. So thank you so much for bringing that to our space this week. Yeah, one more round. Yeah, it's a celebration day. So I'm going to now hand it off to our presenting teams. We're going to start with the Gator Gears. So come on up, Gator Gears.
In 1849, 9 brave prospectors from South Carolina set on a quest for golden land. They traveled on the Oregon Trail for miles and miles.
They faced every peril that you could imagine, but unlike other wagon trains, they overcame them with teamwork and grit.
They call themselves the
Gator Gears.
Hello, prospectors. Would you like to join us on our journey, trekking the west through the Great Plains to find some gold?
The modern-day explorers and archaeologists face a hidden danger, deadly gases and chemicals that can make a dig site a death trap. So we created the
Canary! Canary will help protect archaeologists from any hazardous chemicals, keeping them and our crew safe.
But our expedition isn't complete without packing our wagon full of what truly matters, our core values.
Are you ready to travel on the Oregon Trail with the
Gator Gears.
Howdy, partners. Grab your boots and buckle your britches. We're leaving the safety of the settlements behind for a journey across dangerous plains and mountains.
The unearthed challenge to our team to uncover one truth. The biggest struggle for archaeologists isn't buried treasure. It's the lethal, invisible threat that lurks beneath the dirt.
Our scouts, Derek and Christian, blaze a research trail through a wide variety of sources, from academic articles, library books, podcasts, online videos, and actual dig site accounts for archaeologists.
During our field study at the University of South Carolina, the Anthropology and Archaeology Department, Dr. Adam King confirmed that archaeologists can face poisonous gases like hydrogen sulfide and methane.
Our clearly defined problem is a serious, life-threatening risk of fatal asphyxiation, and permanent neurological injury from invisible subterranean gases leaking from dig sites.
So we created the
The Canary uses advanced gas sensing technology to detect harmful gases and alert the wearer before they're exposed.
After digging deep in research, we wanted to solidify the outline of our design. The main purpose of the Canary is to protect archaeologists from harm, so we created a three-part survival criteria: gas sensing, data logging, and comfort.
Narrow down these must-have features. Our solution had to warn archaeologists, be easy to wear, and provide scientific data.
To ensure full team involvement in our solution, we used our circular protocol.
Each Gator Gear pioneer independently sketched ideas. We then used an anchor chart to compare options.
Geeta then created Google Form to run the first design of the Canary.
The result was a two-part solution: a lightweight wearable bracelet that detects gas, data logging with GPS mapping, combined with an emergency mask for immediate respiratory protection.
Our entire development process is fully documented in our engineering notebook.
For the prototype, we used an old Fitbit watch band as the base, adding specialized gas detectors and vibration motors.
Once harmful gases are detected, the Canary will vibrate and beep, along with an array of lights. This signals the user to utilize their 1 minute of escape time.
Made of a specific aluminum, we also incorporated a water bottle into our design. This innovation makes it a two-in-one solution.
A critical feature of the Canary is its crew-wide alert protocol. The system is designed to instantly broadcast the danger signal, ensuring the simultaneous evacuation and safety of the entire archaeological team, not just the wearer.
Just like the original pioneers, we had to chart the landmarks and map the hazards along a trail.
Our coding explorer, Alia, has engineered an Arduino to instantly detect gas, make the wristlet vibrate, and flash with LEDs. She has also created a trifold board along with Christian and Cushy to showcase our progress throughout this journey.
As our project continues to evolve, we followed initial design reviews based on expert feedback to validate and improve our core features.
The experts told us that hazmat suits were too uncomfortable, and anklets were prone to damage and false readings. We took this back to our circular protocol and made two critical changes.
First, we abandoned the full suit idea, then removed the anklet sensors. This made our wrist-only bracelet our final rugged design to maximize reliability and comfort.
We talked to an analytical chemist, Dr. Amanda Cruz, and shared our research on archaeology and possibly using filters in our design. Using her expertise, we did not use this.
Next iteration was using compressed air instead of pure oxygen.
Pure oxygen is highly flammable and potentially explosive, while compressed air is breathable but not hazardous at all.
Our team also agreed to move to an innovative water bottle feature consisting of 2 chambers. The outside holds the emergency compressed air, while the inside is refillable with drinking water.
Our trail is now lighter and safer. Throughout our journey, we've made sure to share with many others in order to create an impact on our community. Archaeologists across the globe can now explore safely.
For example, we put together a website displaying our team's work this season. We then hung flyers around our schools so our knowledge was available for everyone.
But we didn't just stop there. On Tech This Way podcast, which is available to anyone on Spotify and YouTube, we unearthed our innovation by talking about what we've accomplished so far this season. We're going beyond the walls of our school and sharing globally.
Our coaches found an amazing opportunity to showcase our progress at the STEM night at the Lexington Technology Center.
We are incredibly proud of all we have achieved and are enthusiastic for moving the Canary from a prototype to a life-saving reality.
We hope to expand the Canary locally and globally to impact many archaeologists.
With this new device, archaeologists will be forging a safe digital pathway through history, not charting an unknown risky trail.
Now, let's keep exploring the past without risk of gas leaks
Or dysentery.
You'll be safe on this trail with the
Gator Gear.
Great job, Gator Gears. Let's hear one more round of applause. That was amazing. All All right, so next we're going to have the curious Earthlings come up. So we'll give them a few minutes to set up, and then we'll get started. Come on up, curious Earthlings.
Good morning, Waffle!
Hello, everyone. What if we handed you a pile of broken artifact pieces? No picture, no instructions. Could you put it back together? Well, that is exactly what archaeologists face every single day. We are the Curious Earthlings, and thank you so much for giving an opportunity to stand on the stage. We interviewed experts at the Egyptian Museum and from India and learned about many fancy techs like LiDAR and GPR, which cost millions of dollars. But we don't have millions of dollars. We barely have enough money for pizza. Then, we hit our aha moment, artifact restoration. Only 5,000 archaeologists worldwide have the skill, taking weeks to restore a single artifact. We thought, what if we could give them a superpower? Our answer, Artifactum, an AI-powered app that reconstructs artifacts faster and precise. For everyone, not just specialists. In qualifiers, we showcase version 1, a 2D app powered by prompt engineering. We broke a clay pot, scattered the pieces, tested 35 prompts, and watched the AI rebuild it. Text analysis, 95% accurate. We felt like geniuses. Then, Dr. Shobha, an archaeologist from India, gave us game-changing advice. 2D images don't help. We need 3D models and shared Iron Age fragments.
At regionals, we showed our answer. Artifactum 2.0 and 3.0. We pivoted from prompt engineering to vibe coding using an AI coding tool, Cursor, turning plain English into real software code. We found a research paper funded by the South Korean government working on the same problem, but it was packed with complex math we couldn't understand. So we used Notebook LM to turn it into a kid-friendly podcast and crack the code. The author, Mr. Seung Jong Yoo, shared his knowledge in the South Korean artifact dataset. At first, it was total chaos. The artifacts would not combine until he walked us through the dataset transformation. Boom! Pieces aligned. Artifacts rebuilt. We had rebuilt our entire app around true 3D geometric reconstruction. Now for Waffle. We asked ourselves, what makes Artifactum truly world-class? The answer was scary. We had to go PhD level deep, and we're still in 6th grade. So that's a lot of grade levels.
So me, SFS++. SFS++ is the engine now powering Artifactum. SFS++ is a 2-stage C++ system that doesn't guess what pieces look like, it calculates it. Stage 1 is the preprocessor. We feed it .obj mesh files from 3D scans of each artifact. It outputs 3 things. Number 1, surface files, every single point on the shard's outer surface. Number 2, break line files, the jagged edges where the piece broke off. And number 3, axis files, the invisible center line of the pot, like the ghost of where it used to spin on a potter's wheel. Stage 2 is the post-processor. It takes the pre-processed pieces and runs a matching algorithm that shows archaeologists exactly how every piece connects.
Our current solution successfully reassembles artifacts in about an hour. That's faster than solving a 1,000-piece puzzle, but in a world of instant notifications and instant noodles, we wanted to see if AI could make it even faster. And that's where Artifactum is heading next. Meet Garf, our roadmap. Garf is an AI model trained on 1.9 million fractures.
we've already started experimenting with it on our laptops. The fan spun so hard, we thought it was gonna take off. Let's talk about the impact for our current solution. Text analysis, 95% accurate. Reconstruction, from 2D guesses to true 3D geometric assembly. Our approach from prompt engineering to vibe coding and now to a live app. We spent over 300 hours, and now Dr. Shoba is preparing to send us 3D scans of a 1200 BCE megalithic artifact that her team has been stuck on for weeks. When Artifactum solves it in minutes, that's not a school project anymore. That's history being rewritten.
So here's what we learned. Curiosity is free, teamwork multiplies it, and the right tools can turn kids into people who can understand complex tech. And the most important part, we didn't just use AI, we put it to work. Engineering prompts, research using Notebook LM, coding with AI, and integrating it into an app alongside geometry. We started the season with a broken artifact with no picture on the box. We're ending it with an app that can help the world's archaeologists save weeks of work today and a roadmap to help even more tomorrow. So, of course, all of us had roles in this project. So, just to lay it out for all of you, think about SFS++ as the engine to a car. Our entire team built the car, otherwise known as Artifactum. Me and Yukti were back-end engineers. We basically installed the engine into our car. Abba was a UI designer, and she designed how the car looks like on the exterior and on the interior. And Ishanvi is our AI researcher. She's working on turning our current SFS++ gas engine into an SFS++ and GARF hybrid engine. So we are the Curious Earthlings, and we just help the world piece itself back together. Thank you, everyone, and we will now show you a demo.
Now we will show you a demo of Artifactum. In Artifactum demo, we will show real South Korean pottery. This is artifacts from South Korea that we found in the data set. And you can also do a step-by-step version and remove pieces here. This is our AI analysis print. Here we say a big thanks to Mr. Seong, who worked with us as a PhD researcher. Thank you so much for listening to our presentation.
All right, great job, Curious Earthlings. Let's give them one more round of applause. Now we are going to welcome Powerpuff to the stage to share their presentation.
Some people imagine superheroes with magical powers. We believe heroes solve problems. They ask questions, research deeply, work together, and never give up.
Imagine spending an entire day digging under the blazing sun, moving tons of soil and finding absolutely nothing. For archaeologists, this is not an imaginary situation. It is reality. And today, we will show you how the Powerpuff team turned this challenge into an opportunity.
This year, we set out on a journey to understand the most significant challenge in the field of archaeology. We built a structured work plan, divided responsibilities, held weekly meetings, and dedicated Friday to Research Friday, a day devoted entirely to research, learning, and searching for the right problem.
Throughout the season, we interviewed 15 experts, including engineers, archaeologists, research, and programmers.
We explored a wide range of challenges. For example, Dr. Shira Elbaz explained us the GPS systems do not work in caves, but we realized that this was not a global problem.
Professor Yitzhak Shai and researcher Eli Avisar introduced us to difficulties in sorting and preserving findings, but they also emphasized that these were not the most critical challenges facing archaeologists today.
So we kept searching. During an archaeologist open day at Tel Aviv University, we discovered a particularly significant challenge. Archaeologists divide excavation sites into 2 by 2 meter squares, but they often don't know which square is the best place to begin digging. As a result, they spend countless hours, manpower, and resources excavating completely empty areas.
We examined existing solution. RTK device can accurately mark excavation point, but they often struggle in complex terrain. Ground-penetrating radar can scan under the surface, but it's expensive, difficult to operate, and requires experts to analyze the data.
Then we asked ourselves a simple question. What if archaeologists could know where to dig before they even begin excavating? This is how RoboScan was born.
RoboScan is an autonomous robot that precisely marks excavation grid, scans the ground, analyzes the data, and presents it in a clear and accessible way for archaeologists.
Instead of guessing where to dig, archaeologists can make informed decisions based on real data.
The robot is powered by a Raspberry Pi 5, operates using 2 batteries, includes servo motors, and features a radio wave sensor that enables ground scanning. It moves using a track propulsion system similar to a tank, allowing it to navigate in challenging terrain.
Throughout development, we made several significant improvements. Additionally, we plan to mark excavation grade using stakes and springs. However, after consulting engineer Yosef Moyal, we realized that this approach was limited to the robot mobile.
As a result, we developed a precise spray paint marking mechanism that places a mark every 2 meters in both directions, creating an accurate excavation grid across the site. In addition, we added an aluminum shell to protect the electronic components from external damage.
Throughout the development process, we worked closely with experts in electronics and software, including software engineer Yossi Bitton from Amdocs and electrical technician Vladi Tepper, who helped us build the prototype and develop the operating code.
But RoboScan is much more than just a robot.
Every scan performed by the robot is transferred to PowerUp, a collaborative platform that we develop ourselves. An AI-powered system analyzes the scan data and presents it in a clear visual format, allowing archaeologists to understand what may be hidden beneath the ground.
In addition, all data is stored in a collaborative database that updates automatically. Archaeologists from around the world can share information, contribute data, learn from one another, and build a comprehensive and continuously growing knowledge base together.
Our solution saves time, reduces unnecessary excavation, lowers manpower requirement, improved fieldwork accuracy, and makes archaeologists' information more accessible and easier to use.
We realized the true potential of RoboScan after speaking with archaeologist Pnina Toren-Boars, who told us that the solution could transform the field of archaeologists and even help identify hidden underground hazards, such as ancient cisterns.
This project taught us that innovation doesn't begin with technology. It begins with listening and curiosity and understanding the real needs of the people we are trained to help.
And so, after a long journey of learning, research, persistence, and teamwork, we succeeded in transforming a complex challenge into one innovative solution.
Archaeologists uncover the past.
We created RoboScan to help them discover it faster. Thank you.
Great job, Powerpuff. Yeah, let's give him one more round of applause. All right, next we're going to have Pink Black come up and share their presentation.
Un, dos, tres, soy como el aire, a toda velocidad. Solo estoy yo en mi caminar. Soy como el viento que revienta de repente, una explosión de bomba nuclear. El aire que revienta contra el mar y va gritando contra el viento, rompiendo todos los esquemas de mi piel. Una explosión de euforia y libertad. Tan, tanan, tanan. Shh. I think there's something down here. If it's an artifact, we'll take it to the museum. But what if it's a dirty sock?
Hey, you superstar.
Hey now, you're a rock star.
Excavation superstar. Don't touch anything.
Are people we say archaeologists always mess everything up?
Oof, this soil is drier than hair they left open in the desert. We can't even see the soil layers.
So important information from the past can be lost.
Long ago, there was a very simple technique: watering the soil by hand.
From this question, we started our research.
But that's not how our project started. Tan, tanan, tanan. First, we researched papyrus and how to preserve it after its extraction.
Spoiler alert, we didn't find any papyrus. Katia Galan, PhD in archaeology, told us doing so is nearly impossible.
Harder than braiding your hair in the middle of a hurricane.
But we found a more interesting issue.
Tell me more.
Stratigraphy, the different soil layers that showed what happened first and what happened later, like a lasagna, but a historical lasagna.
If layers aren't clearly visible, objects from different periods get mixed up.
Oh no!
Thanks to stratigraphy, archaeologists identified at least 9 occupation levels in the city of Troy.
And neither Brad Pitt nor Orlando Bloom told us that.
So we had an idea.
What if a robot could measure humidity, water, and help see the layers better?
And this is our solution.
Experts also recommended consolidant to preserve bones.
Which is very important. According to papers, bones are so fragile they could break just by looking at them.
That is because if a bone's been buried for centuries, it adapts to soil humidity.
And when exposed to air, it dries out and becomes very weak. Expert Paragon recommends Polaroid B72 as homemade consolidant.
Which, even though has the name of the final boss of a video game,
it's a resin that mixed up with acetone and water becomes an ideal consolidant because
it can be removed without damaging the bone.
Tan, tanan, tanan. We've been working since September with a weekly plan, setting a project journal on Canva to make sure everyone was involved and aware of our goals.
We visited archaeological sites and talked to several experts such as the Cecil Lab at Universidad Autónoma de Madrid. To research, use papers, podcasts, YouTube videos, and even AI.
Nowadays, archaeologists identify stratigraphy by careful observation, manual excavation,
and they use small tools like trowels, brushes, and small picks.
However, this process is very time-consuming and not very reliable.
There are robots using archaeology for exploration and recording.
And in our culture, that measures soil humidity.
But is there a robot that does both?
Now there is! Lucibot is our prototype. It's a robot that uses Lego motors to move with a custom attachment. There were different iterations of Lucibot until we finally created this final version.
These are our first draft before actually building it.
Tan, tanan,
Ta-nan. We tested different control boards, and finally chose Netha.
It's compatible with microbit and includes many types of sensors.
We program it with word blocks. Here you can see if the temperature is lower than 10 degrees. Flucibot sprays 4 times.
Choosing Netha was like replacing an old car with one that finds response when you press the pedal.
Besides, thanks to its camera, we can see everything in real time.
Like on Twitch.
But we had problems built in it. The arm moved too much and the spray bottle looked like.
And now we are going to show you how it works.
Right now, it is programmed to go straight until it finds an obstacle closer to 20 centimeters, when it will turn.
What if the temperature or humidity are low?
Activates and waters the soil. It could be programmed to adapt to any archaeological sites.
Tan, tanan, tanan.
We tested it so many times that Flucibot calls us by our names. An important change was replacing the arm motor with a servo to be able to program with angles and to be more reliable.
We tried it in different locations and presented our project in several places.
Local schools.
Universities. An international exhibition of technology.
And innovation.
We had video calls with Spanish and international FLL teams and shared Flucibot with experts to get feedback.
The first improvement will be tilting the arm to apply water consolidant directly onto the ground without splashing. Besides, an on-site pulley system could help us to stratigraphy profiles better.
Flucibot could be used during early excavation at your archaeological sites. And when Flucibot does that, we all like to see. I love it when you do it like that. Come on, robot. The rhythm is your. We are Team Black Team from Madrid in Spain. And our presentation, so we hope you enjoy our show.
That was amazing, Pink Black. Congratulations. All right, we are now going to welcome the coding canines to the stage. Come on up.
We're the Coding Canines, Hit 207. We are excited to share our work with you today. Our team focuses on solving problems, exploring new ideas, and working together.
Discovery drives everything we do. As we look for solutions and test new approaches, every challenge is a new opportunity to learn.
Inclusion is important to us. Every teammate's voice is valued, and everyone contributes to our solutions. Teamwork is at the center of how we work.
We enjoy this process and have fun while we build, learn, and try new ideas. This energy keeps our team motivated and creative.
For our innovation project, we notice that archaeologists often have to work in remote locations. Carrying tools and tables slows them down and makes their work harder.
Our solution is the Snap Station, a lightweight portable table designed specifically to help archaeologists carry their tools to remote locations safely and efficiently.
We designed it to have real impact to make field work easier and more accessible.
Next, we'll tell you about a robot design and strategies for competition.
Together, we are the Coding Canines, Team 1259, and we are ready to take you on our adventure.
Welcome to Survivor, Teamwork Island, where teams don't outwit or outplay each other, they out-collaborate to solve real-world problems faced by archaeologists. Will the team survive the engineering design challenges? Stick around. Things are about to get intense.
Team, your first challenge is identify. You must work as a team to discover an archaeological problem. No one advances alone on Teamwork Island.
We started by forming research pairs, and we Googled what archaeologists do and what tools they use. Let's just say they dig digging.
Each pair added their findings to a shared Google Slides file. We dug into Google, YouTube, and FLL websites.
Based on what we researched, we wrote down questions we still had and then met with archaeologist Jessica Irwin.
We also wanted to ask what problem she faces as an archaeologist.
During our Google Meets, I told the team that carrying all my tools from remote locations was hard. If I had 8 arms like an octopus, this wouldn't be a problem. I also told the team that the breakdown of artifacts after removal is an issue.
After our meeting with Irwin, we researched corrosion problems, but discovered there are already many solutions, and that problem got buried fast.
So the team continued to hunt for their problem.
When the team contacted me, I also told them that carrying all my tools from remote locations was hard, and that archaeology often means long hikes with lots of tools.
2 experts, same struggle. That was our aha moment, or as archaeologists say, our artifact moment. We identified our problem.
Team, you have voted. Your problem is archaeologists need an easier way to carry tools to remote dig sites. Way to complete challenge 1. Your next challenge is to design a solution.
Our team began to brainstorm a solution and created the project plan.
We sketched design ideas based on common tools, weight issues, and travel difficulties that archaeologists face.
Together, we brainstormed a few possible solutions: a carrying drone, a tiny robot assistant, and then
We mixed research with creativity and came up with a lightweight wearable table with storage, the Snap Station.
The team has spoken, and y'all have voted for the Snap Station as your solution. Your next challenge is create, and you must build as a team. If it collapses, you don't lose, you just call it an ancient ruin.
We began drafting and building the prototype. Here is one of our earliest models.
We double-checked our expert notes to ensure the model addressed the multiple problems that real archaeologists encounter, because our problem and solution are based on the challenges archaeologists told us they face in the fields.
We designed the table with storage drawers to hold common archaeological tools, while still making it small enough to fit inside of a backpack.
we also integrated solar-powered charging stations with multiple device outputs so archaeologists can charge small devices they use a lot, like phones, cameras, and flashlights.
We also added adjustable trekking pole legs using expert feedback. This will help the table stay stay level on uneven ground. These poles can also be used as hiking sticks. This will help archaeologists walk into history without feeling like they're turning into history.
Team, together, you created a Snap Station. Now on to challenge 4, iterate, or as archaeologists say, dig deeper.
Team has returned to their experts to gain more insight and make any changes according to their feedback. We've also gained 2 more experts to help improve our model.
I love the storage. Just when we get the first aid supplies and sifters. Archaeologists always need sifters.
We also had the opportunity to
talk with a manufacturing expert at regionals. He gave us a lot of ideas on what to produce our model with.
Our manufacturing expert suggested that we use PETG filament instead of PLA. We're able to mass produce this for archaeologists. We would like to look into faster and more efficient methods such as injectable molds.
We were also able to get in touch with mechanical engineer Bryce Johnson. He suggested attaching the adjustable trekking pole legs with lynch pins to make them more secure.
So we analyzed the feedback, updated the model, and together
Snap Station.
The team has completed Challenge 4 and improved their chances of survival on Teamwork Island. Final challenge, communicate. Your team must clearly explain your solution and its impact.
We began drafting. In conclusion, we built our model to fit inside of a hiking backpack. This is our current model. It is smaller than our planned final model, but includes some of the same features like drawers to hold our tools and a work surface.
Our model also includes the adjustments suggested by our experts. For example, our earlier iteration had the solar panels attached to the top of the table. Now, we include a more portable, solar-powered battery pack that can be put away easily in case of the need to move or harsh weather. We also updated the model by adding snap pins to the adjustable trekking legs so the table is more stable.
The Snap Station is an innovative solution because it does not currently exist, according to archaeologist Jessica Irwin. As a result, our Snap Station allows archaeologists to uncover the past so we can prepare for the future.
We've researched together, we designed together, we've created together, and we improved together. And now we will communicate together.
Team, you have conquered all engineering challenges through teamwork, communication, innovation, and discovery. The team has spoken.
And the Snap Station wins Teamwork Island.
Let's give one more round of applause for our team here, Coding Canines. That was amazing. All right, our next team is the SJT Dolphins. Come on up.
Hi, and welcome to the Shark Tank FLL. Today, we're joined by the SJT Dolphins team. They claim their project can transform the science and save our heritage. Will the Dolphins be able to combine the sharks? Let's find out!
Hello, sharks. Let's start this presentation with a question. When was the last time that you have heard a person say, I want to be an archaeologist? It's a fact. Archaeology is facing a communication crisis. People associate it with movies or fiction. And that is not even close of what really is, a science. This leads to funding problems and massive looting, giving a $10 billion black market. And not only that, the story that we lose, a story that only occurs one time.
To understand this in depth, we decided to talk with real experts, such as archaeologist Nagore Sanchez, archaeologist Manuel Garcia, speleologist Domingo Abreu, and Dr. Kathleen Martinez. They confirm the problematic. People don't understand what archaeology truly is, and what cannot be understood can be valued or protected.
We decided to act. We designed a 4-phase step project: investigation, prototype design, talk with users, and iteration. Iteration, and come back with iteration.
Wow, here in your documentation book, we can see you divide the tasks. Some were focused on research, others designed the components, and others handled the programming. That shows a great teamwork and how EPA was born. But can you summarize it for me? What exactly is EPA?
EPA means Portable Archaeological Experience by its Spanish acronym. It's the first simulator that accurately replicates the work of an archaeologist. With the digital part, it replicates the investigation, and with the physical part, it replicates the excavation. It's not just a break the rocks toy, it's a guided scientific experience.
The first step in EPA is found in the excavation zone. With the help of our archaeological records, the user will be able to understand what to do and how an archaeologist works. By excavating the artifact, they will make a hypothesis about what they think the artifact was used for.
Next, with the digital part, the artifact is scanned. The system evaluates whether the analysis is correct. If you get it right, you unlock additional historical content. But let's remember that the important part here isn't just finding the piece, but it's learning to think like a true scientist.
Interesting. I love that idea. We can see it's clearly educational and functional, not as a game, but as a teaching tool for younger generations. Can you explain me the technology behind this?
Hi, I am Lick Technician Adolfo, and today I will explain the components of EPA. First, EPA has kinetic sand to protect their secrets. It has an LCD screen to display the flashcards. It has buttons that are connected to the Raspberry Pi, which is the brain of all this operation, and it has a camera to recognize the artifacts. It's a built-in laboratory.
Okay, it's clear you have put a lot of thought into this. From the digital part to the physical aspects. In your documentation book, we can see that nothing was a coincidence, like the kinetic sand you used. It has a research purpose. But guys, I still have a question. How do you know your project actually works?
Because we iterated Sharkfield. The first version of EPA was just a cardboard box with paper cards. But the problem was that we kept losing the pieces, and let's be honest, it wasn't very engaging for young people.
Next, we pass to ARCA, a 100% digital version, but it have a problem. When we tell the users, they say that it looked like a video game, and we were not searching that.
So, what did we do? We listened to the users' comments and analyzed the errors, and we realized that to reach the optimal version of EPA, we had to combine the two previous ones, and that's how the final version of EPA was born.
We talked again with the experts, and they confirmed the solution. EPA not only sparks interest in the field, but shows the accurate work of an archaeologist.
If we implement EPA in institutions such as schools and museums, we can change how the new generations understand the science. Because let's remember that greater understanding generates more appreciation, and more appreciation leads to the protection of our heritage. So, participants of the WAFFLE competition, are you ready to help us inspire the new generations of archaeologists?
Amazing work, team. All right, and for our final presenters today, we welcome the masterminds to the stage.
Hello, everybody. We're the Masterminds. We're super excited to be able to share our innovative research project with you all today. So, based on this year's challenge, our team came up with the core problem of how can we efficiently and non-destructively pre-screen artifacts for DNA presence? To reach this decision, we looked into several different problem ideas, such as the importance of precise artifact aging, the complications of different documentation methods, and how DNA being damaged during transportation can lead to artifacts losing usable DNA. Two of us looked into each problem area using a variety of resources, such as field trips, expert interviews, we read articles, and we watched YouTube videos, as shown here. Our project manager, Neha, created the project plan and tracked the progress of our tasks. We updated this plan several times based on delays in receiving parts, expert feedback, and task completion challenges. All of this helped us come up with our problem of efficiently and non-destructively pre-screening artifacts for DNA presence.
But where do we find DNA? DNA is a genetic material found in every living organism. It can survive for thousands of years in bones, teeth, and even soil. It helps archaeologists understand ancient humans, migration patterns, and disease history. However, current methods require drilling and grinding the artifact, which damages them, as per the 2018 Smithsonian Magazine article. Transporting artifacts can contaminate DNA from moisture, microbes, and handling. According to a study in scientific reports, only 8% of archaeological samples tested contain usable DNA, and the UCSC paleogenomics lab results show that for testing, it costs up to $1,000 per sample. That means archaeologists spend time and money on samples that don't even contain DNA.
There are existing solutions, but they come with limitations. Some methods are non-destructive, but require experts and are expensive. Others are portable, but still need training. Chemical methods can damage artifacts, and lab testing can be accurate, but results are slow. This means there is no simple, low-cost, non-destructive way to detect DNA on site. These gaps led to our solution.
So, what is our innovative solution? Our innovative solution, ArchaeoSense, is a cost-effective, portable, non-destructive pre-screening tool that uses UV light to detect for DNA presence right away. Based on the study laser stimulated fluorescence in archaeology, we based our solution with a UV light that detects DNA molecules because DNA is a biomolecule. So, uh, our working prototype ArchaeoSense, and we tested with several samples, such as a chicken bone, a tooth, piece of hair, and to show a no result, we used a black piece of sterilized film. Are you guys ready to see how our solution works? Okay. So first, we keep the artifact at a handheld distance. Then we push this red button, and the UV light will turn on, and the artifact will then give off some fluorescence light, and send it to our sensors. This sensor, the AS7341, will detect light emitted, and the internal sensor will detect the light intensity, the guava sensor. Then we send it to a processor, our Arduino Nano, and finally we show the reading on the LCD display, showing the final results, whether there's DNA or not. Our solution is $44.10.
To reach this solution, we explored multiple ideas: a microchimmer to capture DNA, fluorescent lamps, AI-based imaging, and protein-based screening. Discuss the pros and cons of each method to select our solution. We also made several iterations to our solution, as we first started with a basic LED and sensor, then added a spectrometer for better detection, calibration steps to stabilize readings, and finally, based on the constructive feedback from our experts, we added fluorescent dyes to improve detection for larger artifacts.
We shared our solution with several archaeologists and DNA experts like Mr. Lavin, Mr. Romo, and Ms. Derry, and electrical engineer Mr. Delarue, who helped us understand microcontrolling programming and circuit connections. They all gave us feedback that our overall design is great and that our solution can detect human DNA from equipment and tools, which is a problem of cross-contamination of artifacts. We also shared our solution with over 100 people at different STEM schools and libraries.
Finally, the benefits of our solution are: preserves artifact integrity, is accessible and scalable, it's portable and provides real-time on-site results, and reduces unnecessary lab testing for artifacts that lack DNA, leading to time and money saved. ArchaeoSense helps archaeologists focus on the valuable samples and improves research efficiency. Let's sense the unseen with ArchaeoSense. Thank you. And here's our team cheer. We're the masterminds, bold and true. Build it, see it through. Goals aligned, minds combined, one of a kind. We're the masterminds. Thank you for letting us present to you today.
Thank you so much to the teams that presented. It's so intimidating to be up here sharing with everyone. So yeah, let's have one more round of applause. That was amazing. So that concludes our project presentation. So our presenting teams, if you could make your way to the stands in preparation for our award ceremony, and then our volunteers are welcome to sit in the seats here in the middle. We will get started on our award ceremony in just a few minutes. Thank you again, everyone, and congrats, teams. You did amazing.
another song.
Should have them turn the stream on the full camera so the stream can see it. Alrighty, if we could start cha-chaing our way back to the seats, we would love to get this closing ceremony started. Hopefully we were able to get a little bit of our nervous energy out with a little dance party. We'll see how long I can keep the jacket on before it gets too sweaty. All right, as the last people get settled, has everyone had a good time these last few days? I don't know. I want her to hear it all the way down at the president's house. Did everyone have a good time? Yeah. We sincerely want to thank you for coming and celebrating your seasons with us. It's been a fantastic event for fun. For all of us, we love seeing the fun, the excitement, all of the cool things that you have done. And we're about to get into celebrating some of those things with awards. And I really want to keep that focus on you. But I got to do a little business first, because these kind of events wouldn't happen without sponsors, without groups of volunteers, without people working tirelessly behind the scenes to make things happen. So first, I want to give a big shout out to our sponsors. First off, WPI, sponsor and host. Can we hear it so I can keep my job? We are also sponsored by FRC Tees, who made all the amazing event shirts, so shout out to them. And lastly, JX2 Productions, which helps us with all of this lights, sound, video, AV. So let's give them a shout out. And all of the cool things you've been seeing all weekend are going to see a little bit more during the ceremony. We do have loud lights and sounds going on, just so everyone's aware. But that's made possible by this crew of people that's sitting behind the scenes. They've been here till 1 or 2 a.m. every night. So I just want to shout them out personally. We have Justin, Luke, Simon, Alex 1, Tim, Cody, Ben, Alex 2. So let's give them a big round of applause. And last but certainly not least is my staff, who this event sincerely wouldn't exist without. So you all know Mr. Nick Really with no shoes on here. He's the event organizer, makes it all happen. Then we have Dee Wilhelm, who's our judge advisor. So she's gonna come up here with me to help hand out some awards. And then we have Amanda Bissett, who's been answering everyone's questions up in the rec center, so give her a big shout out as well. So our first couple awards are just going to recognize a few volunteers who've kind of gone above and beyond, and we want to give them a little shout out. One of them is one of my students, and we recognized him the other night because he had to go away for the weekend. So our first Volunteer of the Year winner is Ananth, and we have a little slide just so you can see him. All right, and our next Volunteer of the Year is actually two people. These two people are ones that you have interacted with this entire weekend. They've been here since Wednesday, precariously checking to make sure every single mission model and every single table was correct. They know the rules inside and out, and they make sure that we judge the event and we referee the event fairly and consistently across the board for everyone. So I'd like, as the next Volunteers of the Years, to recognize our two head referees, Mike Strickland and Jeremy Moody. And more importantly, they're showing you the way to come on down and get your awards, which is not running and then inevitably taking a face plant. It's walking nice and slow. Come on up. Congratulations, Mike and Jeremy. They're going to come to the center here, to the center. And then we have our photographer, Dan, who's going to take your photo here. Excellent. Thank you, Mike and Jeremy. So as we do these awards, it's your time to shine. So really, I'm not kidding when I say walk calmly down, because I've seen many of face plants. It's not the way you want to remember the event. So you can come on down. You're going to come up the ramp here. Going to get in the middle. You're going to celebrate. You're going to cheer. You're going to look right at Dan, who's in the middle here. He's going to take your photo. Coaches, moms, dads, parents, whoever you are, you're free to come down and take photos as well, okay? And just have your moment in the spotlight. Does that sound good? Everyone got it? We're going to savor the moment. We're not going to rush it, okay? All right, our first two awards are for mentors. And so we do want the winning mentors to come down, but we also invite the students on their team to come with them as well. So we asked each of you to nominate your mentors, and we received dozens and dozens of submissions. And while we can't recognize them all here with a trophy, we do hope that you understand that the mentors are the only reasons your teams are able to exist. So please take the time. Yes. And I'm guessing they give you a lot more high fives than you initiate with them. So just make sure you say your thanks and let them know, because they do so much stuff that you probably don't even know happens, and they really deserve their recognition. So our first mentor award, this is what the kids had to say. They say, this coach has expanded opportunities for students by coaching 6 teams in a single season. They have an organization method for everything, whether it be a bin or a binder. They go above and beyond to support students both during and outside of their practices. They work hard to connect their students with experts and real-world learning opportunities. They inspire their students to work hard, think creatively, and have fun. And a couple of quotes, they said, she is kind and patient, and she listens when we talk to her, and she has been consistent in showing dedication, organization, and extra effort for her students in robotics. And more importantly, she's coached 24 FLL teams and mentored coaches across Alaska. Please recognize Nicole Smith from Team 212, the Dirt Busters. Right to the center. Congratulations, Nicole. All right, our second mentor award. Here's what the students had to say. This coach has been mentoring for 5 years and supporting their students. They ensure every team member has a voice and an opportunity to succeed. They provide unwavering encouragement through challenges and competitions. They inspire their students to grow, not only as robotics team members, but as people. And they embody the values of FIRST through inclusion, compassion, and leadership. And some quotes from the students, they said, "He encouraged me to share my ideas and help me grow into a leader, even when I didn't think I could be one. And he never makes me feel down. He makes me feel like I can overcome anything if I believe in myself." And that sounds like a mentor if I've ever heard one. So please recognize Colby Arnold from Team 904, the Robo Raptors. The Robo Raptors hail from Missouri. Awesome. Congratulations to Mr. Arnold. All right, next up, we asked you all to do a little voting for your fellow teams for some of the next awards. Be honest, there seemed to be a little ballot stuffing going on, but we sorted through it nonetheless, and I think we came out with some good choices here. So the first People's Choice Award was for the nicest pit, and I saw some amazing pits up there, but we had to choose just one. So the winner of the nicest pit award is Team 611, the Coding Pharaohs from Georgia. Right in the center here. All right, congratulations to the Coding Pharaohs. All right, our next award from People's Choice is for Best Giveaway. And I've got a lot of cool giveaways, not from everyone. I'm not saying anything here, but that's okay. The team that was awarded Best Giveaway by their peers is Team 710 WMS Robotics from Massachusetts. Right up in the center. congratulations. All right, and the last of our People's Choice Award is the Team Imagery Award. Let me tell you, all looked amazing. I know some of the kids on my team have already been trading some of you for shirts. That's how good you look. So the people have voted, and the winner of the Team Imagery Award is Team 211 Digibits from Michigan. Right in the center here. Right in the center. There you go. All right, congratulations. Next up, we have the Robot Performance Awards. So you all were here, you had your matches, your chance to earn your high score. We had 2 different ties within the top 5, which is broken by their secondary score, but we're talking 5 points, 10 points here and there. So it was a really amazing competition to watch, and every one of you should be so proud for the work you did. In 5th place for Robot Performance, we have Team 210, the Cyber Dragons, with a 535-point high score, and their second high score of 375. And the Cyber Dragons are from New Jersey. Congratulations. Our 4th place team also scored 535 points, but their second highest score was 485. That's Team 408 Masterminds, and they're from the Virginia, D.C. region. Congratulations, Masterminds. Big fan of the gold glitter hats, for sure. All right, our third place in robot performance with a high score of 540 points, we have Team 801, the Young Innovators League from Slovakia. Congratulations to the Young Innovators League. All right, our first and second place both scored 545 points for a high score. So again, it was the second score that broke the tie. So in second place with their second high score of 520 points is Team 909 Elever from Brazil. Congratulations. All right, it might be harder to be louder than them, but I think the first place team probably can. So with a high score of 545 and a second highest score of 535, we have Llama Drama from Israel. All right. Congratulations to Llama Drama. All right, and now we're about to get into our Judges Awards. So we had a great group of judges all weekend long, listening to all of your wonderful things. And before we get into the Judges Award, I got to take off the gold jacket so I can get on my soapbox a little bit. But I just want to remind all of you that not everyone here is going to win an award. That's the reality of it. But you guys have advanced through your regions, many of you through 2, 3, or 4 competitions to get here. And that in itself is an amazing achievement. So round of applause, everyone. And sometimes you're going to do amazing things and you're not going to get recognition for it. And that's why you need to measure success on your own merit. So if you had a good time, if you learned, if you did conflict resolution, if you made a new friend, if you just advance your skills, that's success. And if you constantly measure your success by someone else's yardstick, it's just a recipe to always feel like you're not enough. So every one of you deserves an award. You guys are in the top probably 1% of the world of teams because you made it here. So huge, huge, huge. All right, so we're gonna start off first with our Judges Awards. And these are awards for teams that the judges want to recognize, but they didn't necessarily fit into one of the other award categories. So our first Judges Award, the judges have called the Bright Future Award because they can see where this team is gonna go. And that goes to team 701, the Who's from Nevada. Let's go wardrobe change, hold on. Congratulations. All right, next up we have the Empowerment Judges Award, and this is going to go to team 103, the Terrific Techs from Iowa. All right, our next Judges Award is for the Brazen Innovative Project Award, and that goes to Team 709 Wahai Robo Warriors from Hawaii. Congratulations. Our final Judges Award, the judges have called the Aurora Award, and it's being given to Team 212, the Dirt Busters from Alaska. Congratulations. Next up, we have our Motivate Award finalists. So for the rest of these awards, there's 4 finalists and 1 winner award. The finalists are in no particular order. So our first finalist for the Motivate Award is Team 401, the Cooling Kids from Mississippi. Right in the center. Good job, guys. Congratulations, Cooling Kids. Our next finalist for the Motivate Award is Team 404, Lego Force from West Virginia. Oh, wait. One more. You didn't wait for the last part, guys. Come on. All right, pose again. Congratulations. All right, our next Motivate Award finalist is Team 305, Brickwall 2.0 from South Dakota. All right, and our last finalist for the Motivate Award joined us all the way from Poland, Team 805, Power Control. right, for our Motivate Award winner, this is what the judges had to say about this team. This team's enthusiasm was evident in every aspect of their journey, from sharing their innovation project with the local community to developing engineering design processes that keep every team member engaged. They consistently demonstrated a commitment to collaboration and inclusion by creating a custom core values chart and ensuring those values guided everything they did. They exemplified the spirit of First LEGO League. Their teamwork, passion, and dedication truly stood out. So congratulations to Team 810, the Electro Eels from Michigan. Congratulations. All right, our next award set is for Engineering Excellence. And again, there are 4 finalists and 1 winner in no particular order. The first finalist for the Engineering Excellence Award is the Creative Koalas from Washington, Team 402. Congratulations. Congratulations. Our next Engineering Excellence Award finalist is Team 512 Sensor Fusion from New York. All right, come forward a little. Right in the center, center up. Our next Engineering Award finalist goes to 309, the Iron Jaws from Slovenia. All right. And our final Engineering Excellence Award finalist is from Illinois, Team 307, Infinite Robotic 96. And now for our Engineering Excellence Award winner. This team demonstrated engineering excellence through a rigorous and thoughtful development process, supported by a detailed data collection and statistical analysis across multiple design iterations. Their wheel optimization efforts provided a standout example of how they use testing and evidence to drive improvements. Through their Kanban boards, engineering notebooks, and comprehensive documentation, they clearly showcased a disciplined approach to problem solving. Every component of their robot was evaluated with the same level of care and analysis. Throughout their presentation, the team's enthusiasm and deep understanding of their work were evident. Congratulations, Team 90911 from Brazil. All right, next up we have our finalists for the Robot Design Award. Our first finalist for the Robot Design Award is from Serbia, Team 104 Aeon. Congratulations. Watch your step. Congratulations. Our next Robot Design Award finalist comes from Oregon, Team 206, the Circuit Breakers. coming? Okay, cool. The rest of them are coming, don't worry. Congratulations. Our next Robot Design Award finalist comes from Pennsylvania, Team 604, Steel Synapse. I'm jealous of all these cool hats y'all have. All right, our final Robot Design Award finalist is Team 304, Gears in Motion from North Carolina. Congratulations. Thank you. Watch your step. All right, and now here's what the judges had to say about our Robot Design Award winner. This might give it away. Like dolphins navigating with intelligence, precision, and teamwork, this team demonstrated a thoughtful and well-engineered approach to robot design. The judges were impressed by their excellent engineering documentation, strong prototype development, clear code organization, and attention to detail throughout their design process. Their ability to test, improve, and communicate their engineering decisions reflected a deep understanding of the engineering design cycle. For outstanding technical excellence and engineering practices, the Robot Design Award goes to Team 601, the SJT Dolphins from the Dominican Republic. All right, next up we have the Innovation Project Award. Our first finalist for the Innovation Project Award is Team 408, the Masterminds from the Virginia, D.C. area. Congratulations. Watch your step. Our next finalist for Innovation Projects is Team 607 Tech Queens from Washington. Congratulations. All right. Dee and I officially decided we need those shoes also, so. All right, our next Innovation Project Award finalist is Team 107, the Awesome Ninjas from Texas. Congratulations. Watch your step. Congratulations. Our final Innovation Project Award finalist hails from Wisconsin, Team 905, the Supercharged Rebels. And now for the winner of the Innovation Project Award. This is what the judges had to say about this team. Great innovation projects start with a real problem, and this team found one that archaeologists face every day. After speaking with 15 experts, they learned that GPS systems do not often work in caves, excavation is expensive, and it can be difficult to know where to start digging. To address this challenge, they developed an autonomous robot that scans the ground and helps archaeologists identify promising excavation sites before digging begins. Using a Raspberry Pi, radio wave sensing technology, AI analysis, and a cloud-based database, their solution can save time, reduce unnecessary excavation, and help preserve important discoveries. And of course, their enthusiasm in their presentation, which incorporated an Einstein costume and a song, made their presentation memorable. Congratulations to our Innovation Project Award winner, Powerpuff from Israel. All right, and now we're moving on to our Core Values Award. Our first finalist in the Core Values Award is Team 903 from Greece, the Grobovines. Congratulations. Our next Core Values Award finalist is from right here in the state of Massachusetts, Team 912, Artemis Rage. Come to the center. Our next finalist for the Core Values Award is Team 303, Gator Gears from South Carolina. Congratulations. Our last finalist for the Core Values Award is Team 112, Brick by Brick from France. Congratulations. Excellent. And now for the winner of our Core Values Award. This team's spirit was impossible to miss. When they entered the room, they brought a splash of color, energy, and enthusiasm that inspired everyone around them. Like two powerful colors working together, they demonstrated how different talents and personalities can unite to create something truly special. Through singing, dancing, confidence, and incredible stage presence, they showcased a team culture built on inclusion, respect, and collaboration. For truly embodying the first LEGO League core values and showing that teamwork is at the heart of every success, please congratulate Team 501 Pink Black from Spain. Alrighty, everyone. So we're about to enter into our final 5 awards, which are the Champions Award. And as you all know well, this award celebrates a team that excels in robot performance, robot design, innovation project, and core values, all of the aspects of First LEGO League. So, but just before, because I know we kind of want to celebrate everyone before we get into this moment, our illustrious production crew has created a rap video to celebrate all of you and to celebrate this event and the fun that we had as a little thank you gift to all of you for coming today. So when they're ready, they're going to roll the video and then we're going to jump into those final awards. Awesome. Thank you so much for coming. I hope that shows you just how much fun that we had celebrating you here at WAFFLE, and we would love to have you back at WAFFLE next year or any time we run robot events on campus. So let's get started with our final Champions Award. What do we think? We ready for it? All right, our first finalists in the Champions Award category, here's what the judges had to say. This team demonstrated exceptional teamwork, organization, and engineering throughout the season. From using a task calendar and a team voting to guide decisions, to completing over 200 test runs and multiple design iterations. They embraced the engineering design process at every step. Their enthusiasm for their innovation projects, combined with impressive growth in programming and robot performance, showcased a true commitment to learning and innovation. Congratulations, Team 801, the Young Innovators League from Slovakia. Congratulations to the Young Innovators League. Our next finalists for Champions Award, here's what the judges had to say. This team exemplifies what First LEGO League is all about. When they weren't researching their innovation projects, they were hard at work iterating on their robot and finding new ways to improve. Their excitement is contagious, and you can hear them throughout the pits cheering, collaborating, and most importantly, celebrating together. Along the way, they overcame challenges that might have slowed down other teams, but they never lost their enthusiasm or sense of teamwork. No matter what drama came their way, they stayed focused on learning, supporting one another, and having fun. After all, that's exactly what you would expect from a bunch of llamas. Congratulations, Team 108 Llama Drama from Israel. Congratulations to Llama Drama. Our next Champions Award finalist, here's what the judges had to say. This team's passion, teamwork, and willingness to learn was evident in every part of their journey. They worked together, they learned from experts, they supported one another, and they showed respect throughout the competition. With their innovation projects using AI to identify artifacts, they strengthened their work by reaching out to experts and exploring how their solution could be used in museums. To top it all off, they ended their presentation with a rap that the judges won't soon forget. They cleverly named a robot featured several. Okay, I'm gonna start that again. Their cleverly named robot featured several innovative mechanisms that gave them the potential to tackle every mission on the field, demonstrating strong engineering and problem-solving skills. Congratulations to Team 703 Timeless from Illinois. Watch your step, watch your step. Alrighty, congratulations, Timeless. Now, here's what the judges shared about our last finalists. This team truly embraced the first LEGO League core values, demonstrating strong teamwork, team spirit, and a clear understanding of each of the core values. Their innovation project was well researched and presented, incorporating valuable feedback from experts and members of their local community. The team followed a highly organized engineering design process, effectively documenting their work and utilizing advanced technologies such as ultrasonic sensors and MicroPython. Overall, they displayed curiosity, innovation, and collaboration through their FLL journey. Congratulations to Team 712 Wu Dynamics from China. Congratulations. All right, now it's time for the big trophy, the Champions Award winner. As you can see, whoever's taking this home, gotta be very careful. These trophies were all designed and built by our LEGO Club here on campus, so we want to thank them as well. They're very cool. All right, and now it's time for our Champions Award winner. This team impressed us from the very beginning. Not only did they create a functional prototype, but they brought a complete business plan, SWOT analysis, and ROI evaluation. Their robot traversed the table with precision, featuring a unique passive attachment that could detach from the robot and complete a mission all on its own. More importantly, this team truly lives the first LEGO League core values. They showed what it means to work together, learn from others, and use innovation to make a positive impact. Their outreach efforts and dedication to their community demonstrated that their impact extends far beyond the competition table. They were finalists here last year in 2025, and now they're the champions. Congratulations to Team Digital from Israel. Congratulations. Give it up one more time from Digital and for all the teams for joining us here this weekend. We truly are thankful that you chose to join us here at WAFFLE. We welcome you back anytime. Congratulations. Thank you all for coming. Please travel home safely and join us next year. Thank you, everyone.